Assalamu alaikum. Our lecture today is about user-defined types or user-defined data types. As we know, there are many different defined data types in the VHDL language library. Some of these, standard logic, bit, and so many others. But if the needed data types cannot be found in the library language, then we must define a new type that may be useful with our task. Similar to the function definition, the user can depend on the built-in function that defined in the language library. But if the needed function is not exist in the library, then the user must define his own function according to his demand. And this is titled as user-defined function. The same thing with the data types. The same thing can occur with the data type. So if the required data type is not defined in the language library, the user can define a new data type according to the demand of his task. This is a special case for VHDL language, and this is one of the important features that characterize the VHDL language. Some of the defined types, as we say, are declared in these two statements. A فرض B in standard logic. So the data types of the signal A and B of the signals A and B is standard logic. The data type of these two signals is standard logic. Here, the signal C is defined as an output signal and its data type is bit. If these types or other types that defined in the language library cannot be useful for our design, then we must define a new data type. One of the main important types that can be defined is array. And the other type is enumerated data types. Now in our lecture we shall focus on array, the data type array. The VHDL language statement for array definition is as follows. This is the statement of array declaration. Type is array of. These words are reserved words of the language, of the VHDL language. Now, this type, by this keyword, we can define a new data type. By using this keyword, we can define a new data type, a special data type that is useful for a special task. Any name you can use it for this type. Any name you can use it for this new type that can be defined. And this type is array. So it have many cells. Maybe 20, maybe 32, maybe 64, any number of data. So this type, not a single data. This type, not a single signal or data. It can combine any number of signals. Now, the number of location or the number of data this type can occupy is defined by this field, integer range. This integer range, we can put 20, 64, 100, any number we needed. Of, now, this defined data type is standard logic or bit or any other type. By this statement, we define a new type. To explain this more, we shall use this example. Here we use the architecture and left the entity part. We use the architecture part only and left the entity part because it is not required here. Architecture of is our architecture named as logic. Of my memory, this is the name of entity which is lifted here. Logic, the architecture named logic of the entity that's named my memory. Now we can define a new data type. Here we name it, we called it mem. So type mem is array. The length of this array is 64 data, is 64 location, is 64 cell. Each cell is of standard logic vector with width 8-bit. So by this definition, we define an array of 64 location, each location with 8 bits width. Each location with 8 bits width. So now we want to define a signal as before. So in our example, we have two variables. We have two signals. The first signal is mem 64-8A. The second signal is mem 64-8B. These two signals. These two signals must be defined in the declaration field. The first signal is mem 64-8A and the second signal is mem 64-8B. Which type can be taken or can be given to these two signals? Which type? Standard logic cannot be useful. Bit cannot be useful. But here we define a new data type, so we can put mem. Mem defined now. Defined in the previous statement. Type mem. This is a new data type defined now in this example, and it is very useful to declare these two signals. So now the first signal mem 64-8A and mem 64-8B will have 64 location. Each location is standard logic vector of 8-bit width. Now the first signal is 64 location, each location with 8-bit, and mem 64-8B is another signal with 64 location. Each location is a standard logic vector, each with 8-bit width. All these can be done only by defining these signals by mem. Mem is a new data type that defined here. Is a new data type that defined here. At this statement, the architecture body starts at begin memory 64.8a must have different value, 64 values, but now we cannot take all these 64 values. We take only one cell, which is the location 12, And for the signal, the second signal MEM648B, we take the location 50. If you want to give 64 values for all the signals, for all the signal location, we can use loop, you can use any other statement. But here we shall take one location of A and one location of signal B. The location MEM648A 12, this location, the location 12, will have this value, A4, and A4 preceded by the letter X. So A4 must be in hexadecimal, according to the letter X. So the value A4 in hexa will be given to the memory cell of A12. And here the value 11110000 will be given to the location 50, of the second signal MEM648B. By this strategy and by this procedure, we can define any new data type, that suitable for our task demands. At this point, the architecture body is ended. The array type can be used for creation two-dimensional data, two-dimensional data types. To create memory can be used to create memory, as in our example, as we see in our example. And to define any data types, for any array, to define array data or array type declaration. In the next lecture, we shall explain the enumerated data type.